are the optical encoders that are used to define the data. So all these things are attached to the shaft. So shaft is one of the most important thing in the design of the our wire scaler. So here's we can see that we're going to see how they actually work. This is the setup, whole setup, and this is the beam going on here. And this is how our wire scanners are placed, and this is how they get rotating. Now, when they're rotating, we can see that when the wire will come in the vicinity of the beam, well, it will interact with the beam. There's a production of secondary beams. So secondary beams interacting with the wire can give us the beam profile like that. We can have a distribution of the interaction with the wire, and this is how we can get an idea about the intensity of the beam, and this is how it is calculated. So the wire position by the number of particles that interacted with the wire, they gives us the beam profile, and we can have idea of the beam. So this is another slide for the design of the beam, design of the wire scanner. This is the vacuum pipe, this is the beam, and we have seen all of it quite in the video very clearly. Alright, so what is the issue that I'm going to talk about here? Is that when the wires of the scanner interacts with the high energy beams, there is a damage in the wire. The wire gets breakdown and the wire gets to face very harsh conditions, like the interaction with high energy beams, there are high temperature conditions there, and a few things happen that I'll discuss, and let's see that what happens with the wire. So in 2002, LHC was not there. It was being used in I forgot the name. It was another another detectors, another accelerators. It was I forgot the name, but there was another detector in year 2002. They for the first time the breakage in the wire was observed. So actually, what happened that the reason was that there was a current produced in the wire, like the beams interacted with the wire, and there was a current produced in the wire that causes the beam profile to be not good. So we realized that something is different, and we detected that there were radio frequency modes that were interacting with the tank of the tank in which the scanner was placed. Actually, radio frequency modes, a few radio frequency modes, because of the interaction of the beam and the wire travel to that tank. And that is the reason our wire failed that time. So it was solved by the addition of ferrites to the scanner tanks to damp out the radio frequency modes. Like the ferrites, they were quite good in damping out the radio frequencies, so they were added there to absorb those frequency modes, and it was solved back then. Then in year 2012,